The battery is the most costly, necessary, and, most importantly, continuous component of an electric vehicle. Electric vehicle opponents typically point to batteries as the primary problem, citing their limited lifespan, need for early replacement, and environmental impact of recycling. Many of these claims were formerly genuine but no longer hold any value. And today, we're going to be covering all of the mentioned areas in this video and focus entirely on electric car batteries to be able to learn how they're rightly designed, their capacity, range, lifespan, as well as types of batteries. So let's get started. There's numerous electric vehicle battery manufacturers. Tesla and Nissan are two well-known examples, while LG Chem, for example, provides electric vehicle batteries to Volvo, Renault, Ford, and Chevrolet. Not only that, but they've also linked an agreement with Tesla to be able to supply batteries for every Tesla produced in China. BYD is China's leading electric vehicle manufacturer, and they're also working on battery storage of electricity for the home, commercial, and industrial purposes. Electric vehicle technology is classified into three different types: hybrid electric vehicles, plug-in hybrid electric vehicles, and battery electric vehicles. Internal combustion technology propels a vehicle by combining combustion and pressure, while electric vehicles, on the other hand, are propelled by electromagnetic radiation. Electric energy is then absorbed and stored in batteries by the regenerative braking system of electric vehicles, reducing energy waste and environmental emissions. While on the other hand, you have internal combustion engine cars, which are acquired for their energy from the consumption of gasoline or diesel. An electric vehicle gets its power directly from a large battery pack. These are reminiscent of the typical lithium-ion battery that you'd find in your smartphone. EVs don't use a single battery like a phone, but rather a pack made up of thousands of separate lithium-ion cells that work together. Electricity is then used to be able to make chemical changes inside the car's batteries while it's charging. When in motion, these changes are reversed so as to generate electricity. And electric vehicle batteries differ from starting, lighting, and ignition batteries in that they are deep cycle batteries which are meant to provide power for extended periods of time. Electric vehicle batteries are also distinguished by their relatively high power to weight ratio, specific energy, and energy density. Smaller, lighter batteries are preferred since they do lower vehicle weight and, hence, increase performance. Most contemporary battery technologies have substantially lower specific energy whenever compared to liquid fuels, which frequently affects the maximum all-electric range of these vehicles. Because of their high energy density compared to weight, lithium-ion and lithium polymer batteries are the most prevalent battery types within modern electric vehicles. Lead-acid, nickel-cadmium, nickel metal hydrogen, and, less commonly, zinc air and sodium nickel chloride batteries are also used in electric vehicles. Let's look at how these batteries are used in electric automobiles. Automobile engines start batteries which are designed to utilize a small fraction of their capacity so as to be able to give high charge rates to start the engine, whereas deep cycle batteries are actually used to supply continuous power to electric vehicles such as forklift or golf carts. Previously, lead-acid batteries were used in most electric vehicles due to their established technology, high availability, and low costs, such as the Detroit Electric Vehicles and General Motors EV1. Nickel metal hydride batteries are now regarded as a mature technology, and when used appropriately, nickel metal hydride batteries can have an extremely long lifespan, as seen by their employment in hybrid vehicles and the surviving first-generation NIM Toyota RAV4 EVs, which continue to work well after 100,000 miles and more than a decade of operation. The electrolyte is a sodium nickel chloride or Zebra battery. They've been utilized in a variety of EVs, including Mosaic commercial vehicles. Zebra batteries are absolutely harmless and can withstand thousands of charge cycles. Demands from portable devices, laptop computers, mobile phones, and even power tools have all propelled development in lithium-ion battery technology since the 1990s. These advancements in performance and energy density have helped to benefit the BEV and HEV markets. Unlike previous battery chemistries such as nickel-cadmium, lithium-ion batteries can be discharged and recharged on a regular basis and at any charge level. In addition, lithium is the lightest metal. However, lithium-ion batteries don't actually contain lithium metal, but instead contain ions. If you're wondering what that is, it's an atom or molecule that has an electric charge due to the loss or gain of one or more electrons. Lithium-ion batteries are also much safer than many alternatives, and battery manufacturers are required to implement many safeguards so as to protect consumers in the unlikely event of a battery failure. Manufacturers, for example, will install charging protections in electric vehicles so as to preserve the batteries during repeated rapid charging sessions in such a short period of time. EV batteries go through cycles of discharge whenever driving and charge when the car is plugged in. The amount of charge that the battery can hold helps to decrease whenever this procedure is repeated over time. This ends up reducing the range as well as time, which is required between charging trips. Most battery manufacturers provide a 5 to 8 year warranty on this, and the current prediction is that an electric car battery would last between 10 to up to 20 years before ever needing to be replaced. The connection between a battery and a car's electric motor is surprisingly simple. The battery connects to one or more electric motors, which move the wheels, and whenever you push the accelerator, the car immediately sends power to the motor, which slowly uses the energy stored in the batteries. Due to electric motors also functioning as generators, whenever you remove your foot off the accelerator, the car then begins to slow down by turning its forward momentum back into electricity. This actually occurs more strongly if you apply the brakes. The regenerative braking recovers energy which would otherwise have been lost, storing it as the battery and extending the range of the vehicle. When an EV's battery capacity to power a car is depleted, it can then be used to power a home or building by helping to contribute to a battery storage system. A battery storage system occurs when energy in batteries can be used later on, and if you use renewable energy like wind or solar, you can link it with an EV battery. Here, you can save it for use throughout the night whenever the wind and sunshine are diminished, or even during the day in conjunction with solar and wind energy. This method of generating energy can even help you save money on utility bills and minimize your reliance on the grid. An electric car battery is a tried and true technology which will survive for many, many years to come. EV makers even guarantee it. In fact, Nissan guarantees that its electric car batteries will last for 8 years or up to 100,000 miles, while Tesla offers a similar guarantee. Now, this may appear as an astonishing claim because whenever the battery in your phone begins to wear out after only a few years, you need to consider that during that time period, it may have actually been fully charged and disconnected hundreds of thousands of times. Each of these so-called charge cycles ends up reducing the battery's life, about 500 full cycles, where a lithium-ion battery begins to lose a substantial portion of its capacity. While it may be sufficient for a phone, it's insufficient for a car built to travel thousands of miles. Hence, EV makers go to considerable efforts to make electric car batteries last much longer. Batteries in EVs are buffered, which means that drivers can't use the entire amount of power stored, minimizing the number of cycles the battery has to go through. Together with other techniques like smart cooling systems, this implies that electric car batteries should last for many years. And in fact, manufacturers ensure that there is extra spare capacity to be able to compensate for degradation over time in order to extend the life of an electric vehicle battery. As electric cars age and their battery cycle, the extra spare capacity is then depleted. This permits the vehicle's range to remain constant during the battery's life. And when the battery capacity falls below 80%, drivers may notice a decrease in battery range and performance. Scientists at the Technical University of Denmark ended up paying $10,000 in 2010 for a certified EV battery with a capacity of 25 kilowatts with no subsidies or even surcharges. 2 of the 15 battery manufacturers could provide the required technical documents on quality and fire safety. According to a 2010 National Research Council report, the cost of a lithium-ion battery pack was around $1,700 per kilowatt of usable energy. And according to a 2013 study by the American Council for Energy Efficient Economies, battery costs fell from 1,300 kilowatts in 2007 to just 500 kilowatts in 2012. There's even some forecasts which have anticipated that the prices would fall to $100 or less per kilowatt by 2030. And that's about the same time as the government aims for 50% of all new vehicles to be sold in the UK to be electric. Plug-in electric vehicles will become more competitive with conventional internal combustion engines as battery technology progresses and production quantity increases. You don't have to be concerned about charging your electric vehicle battery because several manufacturers offer warranties which are up to 8 years or 100,000 miles. That is, even if you needed to replace it in the sad case that something went wrong. It might be covered by the warranty, so always check the type of warranty provided by your electric vehicle manufacturer. Although enabling a second life application can increase battery life, EV batteries must eventually be discarded. Recyclability is not currently a design factor for battery makers, and just 5% of electric car batteries were recycled in 2019. There are 5 types of recycling methods currently available: pyrometallurgical recovery, physical material separation, hydrometallurgical metal reclamation, direct recycling method, and biological metals reclamation. The first 3 processes are described as the most commonly employed. The final 2 approaches are still in the lab, or at least are on a pilot scale, but they have the potential to avoid the greatest amount of mining emissions. VW has announced the establishment of a pilot plant for battery recycling with a goal of recycling 97% of battery components. Batteries will be shredded, dried, and then slaved in this process so as to recover precious metals that can be utilized to produce new batteries. Finally, do electric batteries actually harm the environment? We're going to tell you that the future of EV batteries is looking up. Once their life as a car battery is over, EV batteries can be recycled into the energy cycle for power factories in various households. Repurposing EV batteries could result in a closed-loop recycling system. That is, the factories that make the batteries might ultimately be powered by the recycled batteries once their lives of powering automobiles are through. Large automakers have already begun to reuse EV batteries throughout various applications. Nissan, for example, intends to actually recycle retired EV batteries so as to provide backup power to the Amsterdam Arena, a world-famous entertainment arena home to the Ajax Football Club. All types of batteries might be difficult to dispose of without affecting the environment. The same is true with EV batteries. However, EV battery life manufacturers strive to solve the problem of expensive as well as harmful battery disposals. EV batteries can be repaired to help power more vehicles in the future, in addition to being utilized to assist the usage of renewable energy. Volkswagen Group intends to launch a recycling scheme in which batteries will be graded based upon their quality in order to determine their fate. The batteries that do still have some power will be used as power packs for mobile car charging. The worldwide standard addresses many of the concerns about battery electric vehicle safety. Special training is provided to firefighters and rescue professionals to be able to deal with greater voltages and toxins which are being seen in electric and hybrid electric vehicle accidents. While BEV accidents may offer unexpected challenges, such as fires and smells caused by rapid battery discharge, many experts agree that BEV batteries are safe in commercially available vehicles and rear-end collisions, that they are safer than gasoline-powered automobiles with rear gasoline tanks. Electric batteries are not the most popular types of batteries, nor are they the most commonly used in automobiles on the road. However, as they do get more efficient, cheaper, and easier to dispose of, they have the potential to become the most prevalent automobile battery on the planet. What do you guys think about it? Let us know in the comment section down below. And until then, guys, we hope that we'll see you on the next video, and stay safe and stay informed.